Welcome back! Well, today we'll be going over some examples of the limit definition of derivatives. Well, let's get started. For our first example, we will be finding the derivative of x using our formula, the limit as h approaches 0 of f of x plus h minus f of x all over h, where our f of x equals x. So let's solve this. We have the limit as h approaches 0 of x plus h minus x all over h. Now we can simplify this. X minus x is h over h, which is just 1. So the limit as h approaches 0 of 1 is just 1.
Here, the limit as h approaches 0 of 1 will be 1 because for every value of x, this function has a y value of 1.
Because there's nowhere in this simplified formula that we can plug in h approaches 0, so we would just use 1 as the derivative. For our next derivative, we will be finding f prime of x squared. Now, using our same formula, we take the limit as h approaches 0 of x plus h squared minus x squared all over h. Now let's simplify this. We'll have the limit as h approaches 0. If I expand this right here, I'm going to get x squared plus 2xh plus h squared minus this right here, x squared all over h. Now let's simplify. We can cross out these two terms and we're left with 2xh plus h squared all over h. Now, what I want to do is I want to factor out the h out of the top and the bottom. So I have the limit as h approaches 0, factor out the h, we're left with 2x plus 1h all over, factor out the h, and you're left with 1. These cancel out. So now we have the limit as h approaches 0 of 2x plus h. Here we can plug in the 0. So we have 2x plus 0 with the limit as h approaches 0. And this, once we solve, we get 2x. So the derivative, so if we have f of x equals x squared, f prime of x equals 2x, which we got right here.